Hello, welcome to the Bakwas channel for self-paced tutorials on Internet of Things. This presentation introduces MicroPython examples for the Arduino GIGA R1 WiFi board. This tutorial provides introductory guidance on using MicroPython on the Arduino GIGA R1 WiFi board. The key steps in this tutorial are: flash the firmware to run MicroPython scripts and run some simple examples. A previous tutorial covered the basic features of the Arduino GIGA R1 WiFi board. The firmware on the GIGA board must be flashed prior to running MicroPython. There are a few tasks that must be completed prior to running the first MicroPython script on the GIGA board. These steps are a utility program, the firmware that has to be flashed, and an integrated development environment or IDE. The utility program to flash the firmware is dfu-util. This program will have to be installed on the host computer to perform the flash operation. The firmware file must be obtained from the Arduino site. The two recommended IDEs for development work on the board are Thonny and Arduino Lab for MicroPython. The utility program dfu-util transfers the firmware from the desktop to the GIGA. Download the utility program from the SourceForge site noted on the slide. Always use the published checksum to ensure that the utility program has not been tampered. This check is generally neglected by casual users, but is not a good practice. Make an effort to understand and perform the checksum validation. Make it an integral part of your download operations. The utility program runs on most major platforms. Naturally, the installation method varies with the platforms. For Windows, an extra step may be necessary to enable access for the utility program to the USB device. For Mac and Linux users, the standard method to install packages should work without issues. The dfu-util utility is available in all three major operating systems: Windows, Mac OS, and Linux. In this demonstration, we will be using Ubuntu, and therefore, before we proceed to install the utility, we should customarily use update upgrade cycle to ensure that all our current packages are up to date. For Ubuntu, after completing the update and upgrade cycle, DFU util can be installed using the standard apt install method. Arduino publishes the firmware at its software repository. The link is posted on the slide. This tutorial illustrates the use of the wget utility to download the firmware. In practice, it is much easier to simply use the link provided by Arduino to download the firmware directly. After downloading the firmware, run the utility program to flash the firmware onto the GIGA board using, for example, the command line shown on the slide. The next slide examines the parameters for the utility program. If you are uncomfortable in clicking on a link to download a file, you can use the Linux wget command to download a file of your choice by specifying the precise name as shown in this example. The parameters for the utility program are self-explanatory to some extent. The wait parameter is optional. The alt setting is set to 0 for the first partition on the board to be flashed. This number directs the utility program to select the appropriate GIGA board partition if more than one partition is present. The boot partition is generally 0. There is a specific combination for the vendor product ID pair, as will be shown later in this tutorial. Of course, the download operation must be explicitly specified with the name of the firmware file that will be flashed to the board. The example in this tutorial assumes that the utility program runs from the subfolder location that has the firmware file. After installing the DFU-util utility, check its version number. Invoke the utility and use --version as a parameter as shown in the example to obtain the version number. Use the help option for the utility to obtain a list of all the command line parameters. This information will come in useful later when we flash the firmware. There are some additional utilities that merit consideration. These utilities provide greater insight to the operations and may be helpful during debugging. DFU-suffix provides some basic information on the firmware file that will be flashed to the GIGA board. DFU-util has some parameters that provide information rather than flash firmware. The first one is the -L parameter that lists information about the device. In particular, some useful values like device and product ID pair and alt setting information can be obtained before using these actual values to flash the board. Finally, there is the -V method to log extended information that may be required by the developers of DFU-util to assist in debugging failures in flashing the firmware. You can obtain a list of all the devices connected to the desktop for flashing by DFUtil by using its -L option, -L for list. In this example, there is only one device connected, but the device has 4 different partitions and they are serialized from alt setting 0, 1, 2, and 3. The DFU-suffix, which is a companion utility to DFU-util, provides useful information about the firmware file. To start the firmware installation, prepare the GIGA board to receive the firmware. Press the reset button twice in rapid succession. Wait for the green LED to pulse, which it will do if the reset button is pressed twice within a very short period. Run the utility program to copy the firmware file from the host computer to the GIGA board. There will be a confirmation message in the terminal window where the utility program was run if the board is flashed successfully. After the confirmation message is displayed, press the reset button only once. It will now be possible to explore the file storage structure on the GIGA board using the File Explorer app for your operating system on the desktop. After reassuring yourself that the firmware file is in the folder, you can use the dfutil with the parameters described earlier to flash the firmware to the GIGA board. Double tap the reset button in rapid succession to prepare the board for flashing. The LED light will pulse green. You are now ready to run the dfutil that was discussed previously to flash the firmware. After the dfutil has flashed the firmware, press the reset button once to enable the bootloader operation to be completed. The GIGA board will now show up as a folder under File Explorer. Click on the GIGA board folder and you will see 4 files. Click on readme.txt to get a reassurance that you are indeed using MicroPython now. There is only one MicroPython file there, main.py. You can use the screen utility to connect to this board. And of course, there is always a website available to give you more information about MicroPython. Main.py is the code that executes when the bootloader runs for the first time upon power up. And you can type in any Python commands in here, and you will have to run it as a script if it was some other program. But when it is main.py, it will run automatically. For Linux, use the apt install method to install the screen utility. As you can see in this demonstration, the standard methods of exiting the interpreter are not available in MicroPython when using the screen utility. Use the Control A option to obtain a list of commands that are available under the screen utility. In there, you will be able to locate the command operation to exit the screen utility. The board supports MicroPython with its built-in interpreter that does not require the conventional compilation step. There are 2 development environments for MicroPython: Arduino Lab for MicroPython and Thonny. One of these environments is strongly recommended for MicroPython development work on the GIGA board. Thonny is a very simple IDE for Python users. It is very easy to get started since it has a built-in Python interpreter. Of course, one can use a separate Python installation if necessary. Unfortunately, its simplicity makes it less popular with those wanting eye candy in their IDE. However, even Raspberry Pi Computer promotes Thonny as the default IDE. It has a simple debugger to run programs step by step. The steps follow program structure and not just code lines sequentially. One can step through an expression evaluator. It has faithful representation of function calls. Stepping into a function call opens a new window with separate local variables and code pointer. This is very useful in understanding recursion. There are many other important features that can make a beginner very productive during MicroPython development work. For Ubuntu, Thonny is installed with the classic apt install method as shown on the slide. Under Ubuntu, Thonny can be launched using the desktop icon for applications. Once launched, you will see that it is very simple in nature. It has a menu bar, a toolbar, an upper window for writing scripts, and a lower window where the MicroPython interpreter examines the commands that are typed and interprets them accordingly. While Arduino Lab for MicroPython is supported by Arduino, please note that the current version is still not at the release 1.0 mark. In other words, it is still in the early stages of use in the community. The three major operating systems are supported by Arduino Lab for MicroPython. The installation does not require elevated privileges. The corresponding executable can be launched directly from the installation folder after the zip archive file is uncompressed. The demonstrations use Arduino Lab for MicroPython for the exercises. In addition to the toolbar, the main window in the IDE is split into two parts: upper window for scripts and lower window for command line operations. Arduino Lab for MicroPython is available for all three major operating systems: Windows, Mac OS, and Linux. All one has to do is download the file and expand the unzip file archive and then run the executable. There is no further installation requirements because it does not require elevated privileges for the installation. This MicroPython example illustrates the use of the run command to run a very simple script to blink the onboard RGB LED. This tutorial was a simple introduction to running MicroPython on the Arduino GIGA R1 Wi-Fi board. The prerequisites for running MicroPython were enumerated: flashing the firmware, installing an IDE. Then one of the IDEs was used to demonstrate basic steps to run MicroPython programs. That's all, folks. Please provide feedback in any which way you can. This presentation was prepared with assistance as noted on the slide. My apologies if I have unintentionally omitted anyone or any resource. A very big thank you to y'all. Come back to the channel soon.